Hello everyone, this is Brian recording a briefing video for Project 1 of CSC 143. In Project 1, we're going to explore how class hierarchies, abstraction, and interfaces make up aspects of object-oriented design. In Project 1, we're going to be writing a little world simulation that has interactive buildings like hotels and restaurants. These classes are going to share certain common interfaces, like the top-level building class, and interfaces like business, of which hotels and restaurants are, but each class is also going to have its own independent and unique implementation challenges. For example, hotels offer room rentals for residents, and restaurants serve food to clients. Your task is going to be implementing a pre-designed hierarchy of these interactive buildings. We're going to have some shared properties provided by top-level classes, as well as unique properties like hotels register rental method. Just like with Project 0, you can grab the starter code and open it using IntelliJ. You can follow these extra IntelliJ setup instructions if you have to, and the project doesn't seem to integrate with IntelliJ out of the box, but it should be working the moment you download and open the project. That being said, Project 1 is one of the projects in the class that is not going to immediately compile. It's expected to throw some compilation errors right away. The reason I've designed this project in this way is to encourage you to reason about why the project doesn't compile because expectations about implementation are not being met. We're going to start out with a discussion of these three interfaces that are involved in the project. Business describes a business with a company name, residential describes a building with occupants, and rentable describes a building that can be rented out, namely the hotel. And with these three interfaces, because they're naturally abstract, they're going to obligate any implementing classes to provide implementation for those method declarations. If they don't do so, the project's not going to compile. So that's one of the reasons why the project is not going to compile out of the box. It's going to require you to go take a look at these interfaces and see what needs to be provided. Now let's talk about the classes that are provided in this project. I'm going to give you this lib.pair class. We talked about the pair class when we talked about generics last lecture, and pair is just going to be a container that we're going to reuse for storing two values left and right. At the top level of all of our world classes is going to be the building class. Building is actually an abstract class, and depending on when you watch this video, you may or may not know what an abstract class is. What you need to know to get started is that an abstract class is kind of like an interface, in that it can't be directly constructed, and it can declare abstract methods. That is, methods that are declared but not implemented. So child classes are obligated to implement those methods. Abstract classes, though, are still classes, which means they can have certain things that interfaces do not, such as methods that are concrete and implemented, as well as properties that are internally and shared to other child classes. You can, of course, watch the next few lectures to learn more about abstract classes, but that should be enough to get you started. Next, the store class is going to inherit from building, and the store is going to describe once again, an abstract class that manages inventory and provides a way for clients to make purchases. We're going to use the hashmap class of string to integer to keep track of the current supplies that the store has in stock. Remember, the hashmap class effectively is a dictionary from one type to another, mapping the string to the integer. In this case, it would be something like the name of the supply to the quantity that we have in stock. Again, you're not obligated to understand what the hashmap does underneath and how it's implemented. Instead, I'd like you to just understand the public interface that the hashmap provides and take advantage of that abstraction that it's doing for us. One more level down, we have the supermarket and the restaurant. The supermarket is going to be a concrete class that extends the store, and what it's going to do is it's going to sell exactly what the inventory contains. Be quiet, IntelliJ. There's going to be two methods, get products and purchase. Get products is essentially like a product listing. It's kind of like walking through the store and seeing what's available. Purchase is going to be a method that accepts a collection of pairs, and it's sort of like an order, like Instacart or something like that. You're placing an order for a list of items. That pair of items is describing the name of the item and the quantity. So maybe tomatoes 5, apples 4, inside of a collection. And what purchase is going to try to do is it's going to fulfill the order asked by the client as best as possible. So if the store happens to have tomatoes and apples in stock, what purchase should do is it should return items that fulfill that order as best as possible, as many tomatoes and apples can be provided, as well as deducting those quantities from the internal supply set. The restaurant is going to be a bit more complicated. It's going to be like a store in that you can enter the restaurant and retrieve a list of products that are available in the store. Well, in this case, it's the restaurant, but this restaurant is going to be based on recipes. We're going to use this method, learn recipe, to create a new recipe, like a name, with a name and a collection of items that compose the recipe. The example that I'm using inside this project is actually that of a hamburger. A hamburger can be composed of 2 slices of bread and 1 piece of meat, and we can represent that with the name hamburger as the string and a collection of items of pairs where the first pair is something like bread and 2, and the next pair is going to be meat and 1. Then your getProducts method is expected to determine intelligently how many food items are available inside the store. And what getProducts is going to try to do is it's going to go figure out, among the amount of supplies I have, how many hamburgers can I make? How many salads can I make? Or whatever recipes that are currently registered with the restaurant. Same thing goes for this purchase method. Purchase has to intelligently figure out when a client places an order, represented by this collection of pairs of strings and integers, where this pair is going to be recipes and quantity, so like 2 hamburgers and 1 salad. Among those requests, how many of those can be fulfilled? Each recipe fulfillment has to be based on the ingredients that are being used inside the recipe. For example, if you're going to produce a burger inside the restaurant, you have to consume 2 bread and 1 meat. And ultimately, what you're going to discover is you're limited by the one quantity of resource, of supply, that you have the least of. For example, if you have 3 slices of bread, you can't make 2 burgers because each burger itself consumes 2 slices of bread. So the most you can make is 1.5, but there's no such thing as half a burger in this case, so you'll have to return at most 1. Historically, students find the restaurant class to be the most complicated. This is because it requires a little bit of algorithmic thinking to figure out how we intelligently determine the products that are available based on the recipes and the supplies available, as well as how to detect those quantities from the inside of the purchase method when orders are fulfilled. Last 2 classes involved in this project are home and hotel. These tend to be pretty simple, but it's mostly an exercise in how classes and interfaces interact with each other when those classes are within a hierarchy. Home extends building, hotel extends building, but home is not a business nor a rentable unit. You just have someone that moves in and moves out of the house. The hotel is like a home, but you can register rentals and end rentals for occupants, moving people in and moving people out as necessary. Okay, that's a lot to digest. Let's go actually take a look at the code and see what's going on. We start out with our top level building.java class. It's simply got a location, where that location is just represented as a string. It's got a basic constructor and a getLocation method. That being said, building is an abstract class. Again, you may or may not have learned about abstract classes yet, but what you need to know now is that abstract classes are kind of like interfaces, and they can't be directly constructed. So that even though I have a building constructor defined here, I can't actually call it directly. That being said, by nature of building itself being a class, it having a constructor means child classes are obligated to call this constructor using the super keyword. So it's kind of like an in-between between a class and an interface, in that the building itself can define abstract methods potentially, and child classes are obligated to provide implementation for those abstract methods, but it can also define concrete methods like getLocation that child classes can access via the super keyword. Let's go one level down to the store class, which is also going to be an abstract class. The store is going to extend building and implement business. Let's go take a look at business by control-clicking the definition, and we see that all stores are also businesses. They have a set company and a get company. Remember that interfaces simply declare what methods need to be implemented, but nothing about how they are actually implemented, but I think you can quickly figure out what set company and get company should be doing. Let's go back to the store and talk about the innards of this store class. So don't be intimidated, even though there's a lot of things going on here. I've got an internal string company, which is going to do as you expect. I've got get company and set company. I actually implement that for you. as well as this hash map of supplies, which we briefly talked about inside the specification. The hash map of supplies is going to map supply names to their quantities. So maybe I have slices of bread, so the string would be bread, and the integer is the amount of bread I have, maybe 5 slices of bread. Remember that a hash map is essentially a dictionary, takes us from bread to number. And what I'd like to do with this hash map is have a method that I can use to supply and add new items into the set of supplies, and also say I have some purchase methods that I can use to retrieve items out of the supply. I'll give you a quick introduction on how to use hashmap. We've seen hashmap before inside our university class that we talked about a couple lectures ago, but as a quick refresher, I've got some methods that hashmap gives me. Put is going to associate a key with a value. Get is going to retrieve a value based on a key. Contains key is going to return a boolean that indicates whether or not the key is defined within the map. And key set is going to return us an iterable key set. Remember that iterable items are things that we can either invoke the .iterator method on, or use the for each loop to walk through each element inside the set. I've gone ahead and given you the supply method for free. What supply is going to do is it's going to provide a collection of pairs that is kind of like an import of items into the set of supplies, where each pair is a name of the supply and a quantity. Let's call that the load. Because load is a collection, and collections are iterables, I'm allowed to use the for each loop construct to walk every pair of the collection. Let's go ahead and declare those pairs as P, and for every pair P, if there already is the name of the item inside the set, I'll go ahead and add on whatever existing items there are, plus the new quantity. Otherwise, I'll just declare a new item, type, and the exact quantity that's being provided to me. So you can imagine this hash map being added to by calls to supply, which itself provides a set of pairs that indicates I have 5 tomatoes, 2 apples, and 10 slices of bread. And these are all going to be added on top of whatever existing supplies are inside the store. Down here, I've declared some abstract methods that I'd like the child classes to be implementing. As a store, I should be able to make purchases from the store based on an order, which is a collection of pairs of strings and integers. I provide this convenience method that has the same name as purchase, but otherwise has an argument that's just a single pair, so it's kind of a convenient way to just call the purchase method quickly without having to build a new collection or list. And then I have this get products method, which is supposed to figure out what products are available in the store at a given moment. By the way, you're going to see the interface collection a lot inside this project. I declare this interface collection to encourage you to think about why we would expect these classes to need a collection-like interface, but not have to need a concrete list or other structure kind of class. Let me put that in a different way. The way we declare these orders doesn't have to necessarily be in a particular format. If it's a collection of items, then I can walk through that collection, regardless of what that format is. If it's a list, great, I'll just iterate through it, maybe using indices. If it's a set, great, I can iterate through it because it's an iterable. And so what collection is going to free you to do is it's going to let you decide what concrete class you'd like to use throughout the project. I recommend that you use the array list, because array list is familiar to us, it's iterable, it's even indexable, and it is itself a collection. So the simple thing to do is just to use array list everywhere. But if you want, you can even try other classes like the sets or the maps, which are also collections, and you can of course read the official Java documentation to learn more about the collection interface. Collection itself is going to have methods that are very similar to that of the array list. Of course, the array list is obligated to implement all those methods that collection declares, so I really just recommend you use the array list here. But understand that you're not obligated to do so. You're just obligated to provide whatever concrete class implements collection. Now let's dive into that supermarket and restaurant. Supermarket's the simpler one. supermarket simply has to list out and enumerate the products that are available in the set of supplies, and you also have to implement those abstract methods that are defined up in the parent classes. One kind of cool feature about IntelliJ is if you hover over the red squigglies under the class definition, you'll be told what is preventing this class from compiling. In this case, the error says, class supermarket must either be declared abstract or implement abstract method purchase in store. That is actually a perfect explanation of what's going on here. It's telling us that we have to implement that abstract method because store declared it so. You can either do that by hand, or you can click on this handy implement methods button. And what that's going to do is, IntelliJ is going to go figure out what methods are abstract and don't yet have concrete implementations, and it's going to go give you stub implementations that are going to allow the class to compile, but otherwise aren't particularly meaningful. So here, IntelliJ just gives us return null, which is indeed a concrete implementation, it's just not super useful to us. But at the very least, it gets the project compiling. Now let's talk about restaurant. Restaurant itself is going to have the same things as the store because it's a child of store, but it's also going to have this hash map of recipes, which I've already taught you about how the hash map works. A recipe can be thought of as the name of the recipe plus a set of ingredients, where each ingredient is defined by a pair. So I might have 2 slices of bread and 1 piece of meat to make a hamburger, or something like 1 tomato and 2 pieces of lettuce to make a salad. In order to add recipes, we can use this learn recipe method. And I've already implemented this for you. It's just going to do recipes.put with the name of the recipe and whatever ingredients are provided in the collection of argument. Then of course down here, you need to implement whatever methods that the store obligates of you, which is of course going to be the getProducts and purchase methods. Now, again, students tend to find the purchase method and just the restaurant in general to be the most complicated. And this is because you have to think intelligently about how the restaurant itself is going to advertise what products are available and how it's going to fulfill its obligations when orders come through. If somebody asks for a hamburger, then there needs to be at least 2 slices of bread and 1 piece of meat inside the set of supplies. If there are, then we can provide that hamburger and deduct the recipe requirements from the set of supplies. However, we're ultimately limited by the set of supply, or the ingredient, that is of least quantity. So if I only have 3 slices of bread, then I can't make 2 burgers because I need 4 slices of bread total. So the best I could do is make 1 burger. Let's go take a look at the other side of this project, which is the home and hotel. Home and hotel are actually quite simple historically. People find them the easiest things in this class because mostly actually IntelliJ handles most of it for you. You should go take a look at these interfaces and classes to see what's obligated of the home to compile, and then just go ahead and implement those fields. The hotel is slightly more complicated. Hotel actually implements quite a few interfaces, the residential, rentable, and business interface, and it's going to manage a set of residents inside the hotel with the rental set and the occupant set. We've seen hash set before. It's a collection of items without duplicates. Check out the official Oracle documentation on hash set to learn the public interface. Okay, now let's talk about how you can evaluate yourself on this project. I've broken up this project into 2 phases. Phase 1, which is mostly the store, the supermarket, and the restaurant, as well as phase 2, which is going to involve the hotel and the house, the home, that is. I recommend you work on phase 1 first, and phase 2 second. Phase 2 should be much faster. Phase 1 generally takes more time. Then, when you're ready and you've done everything, go ahead and run the project 1 evaluation. Of course, you may also use the provided run scripts, and I've broken those up into run, which runs everything, and that's the script I'm going to be using for grading, as well as run phase 1 and run phase 2. Let's go back to the project specification, just to review a couple more things. I've also given you a description inside here of how to use these new toys, the hash map and the hash set, as well as a brief introduction to the collection. I don't require you to understand at this time how these classes behave underneath, but I would like you to figure out how to use these classes based on the public methods provided. we've seen how the hash map can be used to map keys to values. And here I tell you how the hash set can be used to track a set of unique items. Make sure to check out these links to the official Oracle documentation if you'd like more details on how they behave. One last note down here is a reminder of how you can use iterable classes. All collections are by nature iterable, and something that is iterable supplies an iterator. This is exactly the same thing that we saw in Project Zero. In Project Zero, we defined a range class that was iterable and provided a range iterator when we invoked the iterator method. Something which is iterable supports the for each loop construct. We can identify the for each loop by this colon here inside the expression within the for statement. And what it's going to do is it's going to walk the iterable provided on the right-hand side and pull out individual values for iteration on the left-hand side. So one way you can walk through all the values of a hash map, that is all the key value pairs, is you can use the key set method to get a set of keys out of the hash map, and then retrieve those keys and then look up the individual items within, invoking the get method on the hash map. So this is effectively giving us the name of the key and the value associated with the key. You're going to be doing this quite a few times within the restaurant class, so I recommend you understand what's happening with the iterable, the iterator, and how this for each loop works. Down here, I give you some instructions on how to run your code. You can either run the phase 1 evaluation, phase 2 evaluation, or what I would recommend actually is the individual test cases that are going to walk you through the specification for the project. As usual with test-driven development, I encourage you to start at the top level test cases and sort of make your way down. At the very beginning, all the tests will fail. Don't be intimidated. Just work yourself through each test one by one. The tests start out pretty simple, and then over time, you're going to add more complexity to your program. Eventually, when you reach the last test, you'll have a fully working program, and you'll get credit for all those tests. As always, I'm going to provide scripts that will run these phase 1 and phase 2 tests. You can do this directly in IntelliJ, or you can do it from your command line. Then finally, when you're done with your project, go ahead and try running the entire project test suite with the run.bat or run.sh scripts. These scripts are going to be the ones that I run when I grade your project, and of course they have to run because I'm going to run them, and if they don't work, then your project doesn't compile on my machine, and I can't give you a grade. As usual, when you're ready to submit, we're going to submit on Canvas. Make sure to zip the top level CSC 143 project 1 folder, fill out the README with your name and whatever details, and then maybe take a look at these critical analysis questions. I put these critical analysis questions here to make you think about what's going on inside the design of this project. What additional flexibility does interfaces provide over abstract classes? Why do we use the collection interface? And so forth. You're welcome to talk about these with your other classmates on Piazza. And these questions are going to be similar to those that I'll ask on the exam to evaluate your critical thinking skills about the way we design software. Okay, that's all I've got for Project 1. As usual, don't hesitate to reach out to me over email or on Piazza if you have questions. This project's due date is going to be on the class schedule and on Canvas. Thanks for listening, and I'll talk to you next time.